Hello everyone. Till now we had talked about the very basic shapes which were formed by joining two shapes together. We had talked about the oil tanker which was formed by the combination of a cylinder and two hemispherical ends. Then we had also seen the ice cream cone which had a conical base and a hemispherical cream at the top. So now let's talk about something different. Now let's take a right circular cone and let's remove a portion of it by cutting a plane parallel to the base of the cone and then removing out this portion. Now this is a very familiar portion and you might have seen many solids similar to this shape. You might have seen the glasses, the flower pots and many more shapes which relate to this shape. We call this shape to be the frustum of a cone, and you will observe that it has two circular ends, one at the base and other at the top, and both these ends have different radii. So let us try to find out the volume and curved surface area of this frustum of a cone. Now for that we can easily find out by subtracting the volume and curved surface area of this smaller cone from the bigger cone, and we can easily get out the values of volume and surface area of this frustum of a cone. Now for that we need to have the dimensions first. So let's give the dimensions to all these terms. So let's say that the dimension of this bigger cone are marked by 1. So let's say that its radius is r1, its height is h1 and its slant height is L1. Let's say that the radius of frustum of a cone is R2 and this radius is already R1, and let's say that its height is H. So we can say that the radius of this smaller cone will be R2 and its slant height will become L1 minus L and its height will become H1 minus H. Now just focus on this triangle and this triangle. Now if you focus on these two triangles, you will observe that these two triangles are similar in nature. Just see that one angle in both the triangles is 90 degrees and this angle and that angle are alternate angles. So it has two angles equal. So we can say that these two triangles are similar in nature. And since these two triangles are similar, so their corresponding sides will be in the same ratio. So we can write down that their corresponding sides are in same ratio. So we can write down that h1 minus h upon h will be equals to r2 upon r1 minus r2 and is equals to L1 minus L upon L. Now if we divide this h from the whole term and this L from the whole term, we'll get this will become h1 by h minus 1 is equals to, this will remain as it is, r2 upon r1 minus r2 and is equals to, this will become L1 by L minus 1. Now if we add 1 to all these three equations, what will happen? This one will get cancelled and that one will also get cancelled. What will remain? This will be h1 by h is equals to, let's take the LCM here. So LCM will be r1 minus r2 and this will be r2 plus r1 minus r2. So this will get cancelled and this will be equals to L1 by L. Now from these two terms we can get the value of h1 and these two terms we can get the value of L1. So let's write it down. h1 will come out to be hr1 upon r1 minus r2. Similarly, the value of L1 will be R1L upon R1 minus R2. So these two values we can get H1 and of L1. So by this activity we had converted the dimensions of this bigger cone into the given dimension of the frustum of a cone. We had converted H1 in terms of H, R1 and R2, and we had converted L1 in terms of L, R1 and R2. Now we can say that the volume of this frustum of a cone will be equals to the volume of the bigger cone minus volume of the smaller cone. So we can write it down. The volume of bigger cone will be 1 by 3 pi. Its radius is R1. So this will be R1 square and its height is H1. Minus, we have to subtract the volume of smaller cone. So this is 1 by 3 pi. Its radius is R2. So it will be R2 square and its height is H1 minus H. Now if I take this 1 by 3 pi H1 common from these two terms, will get, this will be 1 by 3 pi H1. This I had taken common from first term and second term. So what will remain? Here will come R1 square and this is minus in between, so we'll get the minus sign and this is R2 square. And this third term will remain. So this will be minus minus plus. So we can write down plus 1 by 3 pi R2 square H. Now we can put the value of H1 from this equation in this and solve it. So this will come out to be 1 by 3 pi. Put the value of H1. H1 is HR1 upon R1 minus R2, and we can convert this is nothing but A square minus B square. So this is A plus B into A minus B. So this will become R1 plus R2 and R1 minus R2 and plus this term. So put the value, this is 1 by 3 pi R2 square H. Now if you observe, this R1 minus R2 and this R1 minus R2 will get cancelled. So these two terms will get cancelled and we can get 1 by 3 pi H. This we can take common from both these terms and this will be R1 into R1 will be R1 square. So this is R1 square plus R1 into R2 will be R1 R2 and plus R2 square will come from here. So this will be R2 square. So this is the volume of frustum of a cone in terms of the height of the frustum of a cone and the radii of bottom and top. So this we get the volume of a frustum of a cone. So in the similar manner, we can also find out the curved surface area of this frustum of a cone. Curved surface area will also be equals to the curved surface area of this bigger cone, and we have to subtract the curved surface area of this smaller cone. So curved surface area will be, the curved surface area of the bigger cone will be pi, its radius is R1 and its slant height is L1, minus the curved surface area of the smaller cone, this is pi, its radius is R2 and its slant height is L1 minus L. Now if we take L1 common from these two terms, we'll get pi L1, this we had taken common, and this will be R1 and minus R2 will come from this term. So this will be minus R2 and plus minus and minus will become plus. So this will be pi R2 into L. So we can write down pi R2 into L. Again we can put the value of L1 from this equation. So we'll get pi, the value of L1 is R1L upon R1 minus R2, and this is R1 minus R2 and plus pi R2L. Now if you again observe, this R1 minus R2 and this R1 minus R2 will get cancelled. So let's cancel them. And we will get this pi L can be taken common from these two terms. So pi L, and in bracket we'll get R1 plus R2. So this is the curved surface area of this frustum of the cone. Now if we look at the total surface area of this frustum of a cone, we have to add the area of base and the area of top of these two circular ends. So we'll add this curved surface area to the area of base of this circle and this area of base of this top. So we can write down the total surface area of this frustum of a cone. We have to add this curved surface area, which is pi L R1 plus R2, and plus this will be pi R1 square plus pi R2 square. So this is the total surface area of this frustum of a cone. So all we have to remember is the volume of frustum of a cone, the curved surface area of the frustum of cone, and the total surface area of frustum of a cone, and then we'll apply all these three results to solve the questions further.